Hey guys, today we're gonna learn about one-dimensional kinematics. So the three main protagonists we are going to be dealing with in this one-dimensional kinematics story are, you probably already know them, speed, distance, and time. Now these three guys, you can relate them through an equation, which it's pretty uncommon that you may have not seen it before, everyone has. It's just speed is equal to distance over time. We all the time we hear, oh, 60 miles per hour. That's just simply distance divided a time. Okay, when you have, for example, 60 miles over 1 hour, what you're saying is that in 1 hour we are moving 60 miles, and that is what we define as a speed. Okay, how much you're moving in a specific amount of time. So now this equation is different from another equation that is a bit more accurate. And now this equation is dealing with scalars. Speed is a scalar because you're only describing numerically with just one number how much you're moving in a time. And distance is also a scalar, which is just a number to describe the space between two locations or objects. Now this equation is not the same as if you said velocity as a vector is the same as s vector. Now s in this case is displacement, and now we do not use d because when you get to calculus, maybe when you're going to take a derivative, I remember you say d something over dx most of the times, or maybe another variable. But you would say, for example, the derivative of position or distance, dd, that's just awkward notation and we don't use it. If you don't know what this is, don't worry about it for now, okay? This is just, in physics, we do not say in terms of vectors that distance, or we do not represent distance or displacement with d, but rather with s. And now it's pretty similar, but now you have velocity is equal to displacement divided a change in time. And now that change in time is just simply the same as an initial time, which let's say it is, no, it's actually a final time, so TF, final time, minus initial time, okay? This is final, hope you guys can see it from there, and this is initial. Now you guys, in following examples, you guys will see what this means and the intuition on that. So now these two equations, they are not the same thing. Here we're dealing with the scalars, and here we're playing with vectors. And remember, when we have a vector, we also have a direction, not only a magnitude. So now the thing about particularly this equation, is that it's pretty cool because you can derive a lot of things from that equation, which is just pretty amazing. But for now, I'm going to do some pretty simple problems, and then we're going to get on some derivations of some bigger or larger kinematic equations, okay? Now let's do a pretty simple problem to begin with. We have that Jose travels 30 miles in 6 hours. What is Jose's speed? Now, we know from our previous equations, and pretty much from just logic and intuition, that speed as a scalar, remember, we're not dealing with velocity here because we were asked his speed, would be equal to distance divided time. And now we know that, well, we need to find s. So we have a distance, which is 30 miles. That is how much he's moving. So we have 30 miles. I'm just going to write my. And all of this is divided by 6 hours. And 6h. Now this is the same as if I said that, just so you guys see how the units interact with each other. So this is the same as if I said 30 over 6 times miles divided hours. This is just factors that the coefficients, or these are, you could say maybe like see it in an algebra way. This is x and this is y, and they have coefficients. And now you can put them outside of the equation, or the expression, not the equation, the expression. And you would get this. So now 30 divided 6, we know that is 5. And now we have 5 times miles divided hours. This is the same as, well, Jose is traveling 5 miles in 1 hour. That is Jose's speed, okay? Now, I recommend you use, probably to, when you're a beginner, you use this type of writing or notation. Take the units outside so you can see how they interact with each other. When we're dealing with acceleration, you're going to see why acceleration, we define it as a distance divided time squared, okay? You're gonna see why this is the way it is. Now, let's say we have this problem. It's pretty simple. Mike ran 6 kilometers in 10 minutes, heading north. What was his velocity? Or what is his velocity? This is in present tense. So, now what you need to notice first is that we're being asked his velocity, not his speed. So in this case, the right notation to use is the following. Velocity is equal to his displacement divided by the change in time. Now in this case, this is the same. I mean, mathematically, you're gonna get to the same value as if you set S is equal to D over T, okay? But the most accurate notation is this one. Now we know he was traveling 6 kilometers, so let's find velocity. So we would get 6 kilometers divided by 10 minutes. And now you see something wrong here, right? Now you could go with, of course, well, you could simplify that and get that is equal to 3 over 5 kilometers per minute, or 3 kilometers every 5 minutes. But sometimes, well, actually not sometimes, the convention in physics is that we represent velocities as with a denominator of 1. So in 1 unit of time, how much are you moving, okay? So we cannot leave it like 5 minutes. So what do we need to do? Well, we need to play with the units. So we know what should we give the answer in? We're going to give it in meters per second, okay? Which is the SI units. So International System of Units. If you don't know what SI means, that is what it means. That's what it means. So we've got 6 kilometers. So we know 6 kilometers is equal to, so remember, kilo means 1,000. Kilo means 1,000. So if we have 6,000 meters, or 6,000, or 6 groups of 1,000 meters, that's the right way. So if you have 6 groups of 1,000 meters, that's just simply saying 6 times 1,000 meters. And this is just simply equal to 6,000 meters. Okay? It's pretty simple. Just know that each kilometer, since kilo means 1,000, each kilometer is 1,000 meters. That is why it's called kilometers or kilometers. And you have 6 of them. That's just going to be multiplying 1,000 by 6. And that will give you how many meters you have in 6 kilometers. And now let's go with seconds. So, or time. So in this case, we have 10 minutes. We know each minute is, so we have 10 minutes. And now we know each minute is 60 seconds. So if we have 10 groups of 60 seconds, how much is that? We know one group would be 1 minute, and 1 minute is 60 seconds. And we have 10 groups of 60 seconds, that's just going to be 10 times 60 seconds. And this is just simply equal to 600 seconds. And this is our time. Now, what do we need to do in this case with, you might be thinking, changing time. Oh, and by the way, maybe I didn't explain this, or maybe you don't know. When we have this triangle right there, it's what we call delta. Delta is just simply saying that the change in something, okay? The net change in any quantity or variable that you have. So now with those two values, now let's solve. So the displacement, we know it would be 6,000 meters to the north. Remember, in this case, displacement, we're taking displacement, so we're playing with a vector. So I'm just going to write north is going to be divided by the change in time. The change in time is going to be our final time. Let's call it TF, or TF minus TI, you could say. Now, what is our final time? Well, that is when he stops running the 6 kilometers. So you would have 600 seconds minus, and what was the initial time? Well, that is when he started running the 6 kilometers, which is just simply 0 seconds. And so you're gonna get that this is equal to 6,000 meters north. You can't forget about the direction, divided by 600 seconds, I'm sorry. And now this would be equal to, so we know we can cancel out this, and we would get 60 meters to north divided by 6 seconds. And this is just simply, now we're going to do the game of the units. So I'm going to go down here. So we would have 60 over 6. And now you would have meters times meters divided seconds. North is just simply outside, okay? That's not something we're going to be playing with mathematically. So now let's solve this. So we know this is 10 times meters divided seconds. The same thing as if you just take this number and multiply it by m and put it on top of the s, okay? I mean in the numerator. So this would be our answer, and of course, what are we missing? North. Cool. This is Mike's velocity in the scenario that we were given, 10 meters per second. So I hope you guys enjoyed this video, and in the following one, we're going to be playing with time, okay? We're going to be solving for time.